The vibe leading into this spring break is obviously way different than any other year in the past, but I think it's exciting nonetheless. Being able to take a week away from this type of learning and really reflect on what's going on, I think is an important thing. I posted that discussion topic the other day. I wanted you to give me feedback on things that I'm doing well and things that I can do better to help you learn more during this process. And the idea was also to get you reflecting on what you're doing well during this different kind of learning, as well as what you can improve upon. So I want you to continue doing that over spring break. Today's video, I'm only going to go over a couple of problems. It is still all review, continuing what we've been doing the last couple of days. But when I am done with the video, I will go in and write in all of the answers. So I would say when the video is done, pause it, continue doing it, and then play back to check your answers. So let's take a look. We're doing more factoring today. The first couple of problems are getting you built up and warmed up for when we're actually doing the factoring. So things like greatest common factor, or just factoring something out of just some binomials. Or when we get to number 3, it's combining like terms. One thing to point out is that's an addition sign and that's a subtraction sign in between. So you're not actually distributing or foiling type of thing with that. You're combining like terms. And with B, don't forget that -1 that's out in front gets distributed to all 3 of those. Then as you move on to number 4, that's going to be actually doing the FOIL method. Or on C, you're just distributing that 3x squared. Then we get to kind of recognizing the pattern. For number 5, it's all about finding that missing piece, kind of like a puzzle. The thing I want to focus on here is a couple of problems with number 6. More practice with actually factoring. And some call it the diamond problem or the X method. So I'm going to do a couple of these, and then I will post all the answers right after at the end of this video. So let's start with number 6A. So to do the whole X method, there's a 1 out in front here. So it's like 1 times 12. That number gets written up top here. Then this one right here, the +8, gets written in the bottom. So we're thinking 2 numbers that multiply together to be 12 that also add up to be 8. So our factors for 12 are 1 times 12, 2 times 6, 3 times 4. So which of those pairs add up to be 8? Well, it's 6 and 2. Because it was a 1x squared there, we write each of these terms over 1x. And then our 2 factors, you kind of turn these on its side, and it's a 1x and a +6, so 1x plus 6. And then for the other one, you have a 1x and a +2, so a 1x plus 2 are our factors. So our final answer is x plus 6 times x plus 2. When we get to a problem like number 6E, the idea is the same. You're taking this 2 times the -9, that gives you -18. And then the -7x gets put there. So we're thinking factors of -18 that add up to be -7. It's going to be 1 positive, 1 negative in order to multiply to be -18. And it turns out it's -9 and +2. Because it was a 2x squared out in front, we're going to write each of these over 2x. And we're going to look to see if it simplifies in any way. This one on the right reduces. 2 over 2 reduces to 1 over 1. So our two factors, like we highlighted on the last one, this one would be a 2x minus 9. And then over here, our reduced one would be the 1x and a positive 1. And you're getting x plus 1. There's our final answer. And remember, this whole thing is, if I were to FOIL our answer, you get what we started with. That's what factoring is doing. It's like undoing the distributive property, or FOIL. Let's take a look at one more problem, one like letter H. So this is called a difference of two squares. Difference, we're thinking subtraction. Two squares meaning they're perfect squares. The whole little X diamond problem still works on this. So we have the 1 times the negative 64, but then there's no x's in the middle here. So that's what you're putting down at the bottom. So it does look different, but it still works. And you're thinking, what two numbers multiply together to be negative 64 that add up to be 0? So to add up to be 0, they have to be opposites of each other. So what two numbers actually multiply to be 64 that are opposites? Negative 8, positive 8. Because it's a 1x squared out in front, you're putting the 1x there. So our two factors become x minus 8 and x plus 8. If you look, though, the square root of 64 is 8. And that's the two numbers that you're getting here. It's just that one's going to be positive and one's going to be negative. That pattern works every time for a difference of two squares. So it has to be the minus sign right there in order for it to work out. So that's just a special pattern that I want you to look for. Let's go ahead and have you pause the video, finish doing the rest of them, and then when you're ready to check the answers, I'm going to now actually just write in the answers, and I'll post the answer key eventually too that might have some of the work involved. Have a great day.